I nominate this as the easiest lesson of the chapter. But here's what's going to start happening very soon. You're going to start to recognize that the issue here will be keeping track of all these different things. Yeah. So, yeah, be totally bored if you want through this, because this is pretty nice. Okay. We'll use x squared as our motivation. And you've totally seen this whole progression in grade 10. X squared does not need specific x values. We can square anything, so why not use -3 to 3? If you're not sure what x values to use on a table of values, start with -3 to 3. That'll be enough to at least give you a hint as to what to use. So I hope that squaring isn't a big challenge for you. -3 squared, +9. -2 squared, +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. How long did that take me? 10 seconds. So if you are stuck and your brain has a moment of, I forget which one's which, just take a second, build a table of values, it'll be all right. Now, today, instead of adding or subtracting or putting negatives in there, we're just multiplying by a number. And I use 2 to get the idea, but it doesn't really matter what number we're talking about. So by using 2, my new function is, separate color, 2x squared. Hi there. Hi. Welcome, welcome, welcome. No, not at all. I had to class, so. That's okay. Actually, we have the perfect spot for her, I think. Just the right place to be. What's that? Oh, you fibbed me. Yeah. Not on purpose, though. It's not a lie if you thought it was the truth. Welcome. Welcome. Here, right here. You'll find out why this is such a great spot for you. Okay? It's perfect. It's perfect. We're just doing this note right here. Okay, you can just fill things in. Do you need a pencil or anything? Or are you good? She's good. She's good. All right. Welcome, welcome, welcome. Folks, we have a new student. Make her welcome. She's going to keep up with us wonderfully. Yeah? Okay. Here's what you could do. Here's what you could do. I could just take these ones and multiply by 2. That's not what I'm going to do, but it works. It's all that's going on here, okay? So I'm going to go 2 times -3 squared, because I'm using this function. And -3 squared is 9, but I'm multiplying that by 2, and I get an 18. You should be unimpressed. You should be like, really? Did I really come in for this class on a Tuesday for this? And the answer is yes. This is all part of the juggling procedure. Today we're working on bowling pins, or I don't know what. We're just adding a new weapon into the juggling procedure here. So then 2 times -2 squared. -2 squared is 4, which is what's on the other table. Then multiply by 2, and I get 8. Your mind's moving, it's processing, it's going, oh, what's going on here? Oh, we're just multiplying the y's by 2. Yes, you're just multiplying the y's by 2. Lesson over. Lots of details to show you. Lots of little tricks to show you, but that's basically what's happening. 2 times -1 squared is 2. 2 times 0 squared, I hope you don't need your calculator for that one. 2 times 0 squared, 0. 2 times 1 squared is 2. 2 times 2 squared, 8. And 2 times 3 squared is 18. My 8 didn't look too good there. I don't want anyone to complain about my writing, so I'll fix that up. Not part of today's lesson, but just to scratch into previous knowledge, this parabola follows the 1, 3, 5 pattern. Does that ring a bell from grade 10? Yes. This one doesn't follow that pattern. It goes up by 2, 6, 10. It multiplies the pattern by 2. We're not really using that today. I just mentioned it, if that's in the back of your brain. All right. Now what happens if we do 1/2? There's only 2 types of numbers we can multiply by. That's the only tough part in the whole lesson. There's numbers that are bigger than 1 that make the numbers bigger. And there's numbers that are smaller than 1 that make the numbers smaller. That's the only 2 types of numbers we got to worry about. You say, what about negatives? No. Negatives we did yesterday. We know what negatives are going to do. Yes, there's a juggling problem coming. What if there's negative and a number? Yeah. Coming along soon to a 11U class near you. But half f of x would then be half x squared. And I'll show all the steps I'm going half of negative 3 squared, which is 9 over 2. And you know I like fractions. You know I like fractions.
How is it still x squared?
Oh, because it's saying the original f at x is x squared.
Oh, okay.
And it's saying half f at x, so half of x squared.
I know it's
Yeah, okay, good. Now, 9/2 is good. You know I love fractions. And we love fractions because they give the exact amount. However, if I'm going to go graph this, it's possible. I'll write it in red. You can imagine me sneering as I write this, like, oh, I don't want to do decimals. But to graph it, I probably want the 4.5. I probably do. Yeah. Then half of negative 2 squared. Negative 2 squared is 4. So that'd be 4 over 2. Which it doesn't make me sneer. To do 4 divided by 2 is 2. It doesn't make sense to leave 4/2 as 4/2. Okay. 1/2 negative 1 squared would be 1/2, which again, to graph it, maybe you want the decimal. 0.5. Oh, how did I get to orange? I guess I pressed orange. I didn't want that. I wanted red. I love my active board, even though it's old. Half of 0 squared. Okay, well, come on, folks. Yes, I like punching things into a calculator, but let's not get carried away. Half of 0 squared is 0. Half of 1 squared equals 1/2. But again, we probably want the decimal to graph that thing. Half of 2 squared would be 4 over 2, which is 2. Are you bored? I hope you are. Yeah, that would be good news. We got problems coming up with combining these functions. So this hopefully is boring. You're like, I can do this. This is no problem. Half of 3 squared, 9/2. Again, if we're going to graph it, 4.5 is the number. Are we good so far? Well, so far, Mr. Todd, all you did was take x squared and multiply it by 2. Multiply it by 2. What did I multiply by 2? That's the key to the lesson. What values got multiplied by 2?
X, like, to the power 2.
the y value.
The y values got multiplied by 2. The x values stayed the same. I can give you an example why that's true. Let's imagine for a second that my bank account. Yes? So now we're just number of days and amount of money Mr. Todd has in his bank account. And on day 2 of the month, I had $1,000. That never, ever happens when you have 4 children. They can sense it when there's money in your account. But let's just pretend. And I said, we're going to double the money in my account. What would my new table look like? If I doubled the amount of money in my account?
4 and 2,000.
No. That's the key point to the whole lesson.
2 and 2,000.
2 and 2,000, right? When I say double it, you're like, okay, double everything. No, whoa, you don't double the days. Just because I doubled the money doesn't mean it suddenly becomes day 4. Wouldn't that be a weird effect? Say, Mr. Todd, we're going to double the money in your account. Okay, it's October 2nd. Double the money account. And suddenly it's October 4th, and I time traveled forward. Like, what happened? No, you don't double the x. You double the y. Could you double the x? Could we double the day? Yes, but it wouldn't be a vertical stretch. It would be a horizontal stretch. Okay? So a vertical stretch is just the y values. Key minute and a half and the whole lesson right there is like, oh, today it's double the y's. And giving away what's going to happen next on these graphs. Okay? So I got red, blue. I didn't change colors. I forgot. Okay, so this one I will graph in the color black, okay? So on my screen. You got some choices to make. Here's what I suggest you do. Graph this one very lightly. I'll do it in red, but you should do it very lightly. Your base function, your initial one, not the one you really want to see, the one you're going to compare to, do it lightly. So the x squared one in red. Look at how fast I'm doing it. I didn't need the table of values. Maybe you don't need the table of values for y equals x squared anymore. I can do it on the fly. Do you have to do that? No. But look, 4 squared, 16, boom, I can just do them like that. So maybe you're getting to the point where you're good enough at x squared where you don't need an initial table of values. There's the initial function. We'll call it the base function moving forward. And I'm sorry, hopefully you can do a better curve than me. My hand is catching on the active board as I write there, but not bad. It's the base parabola from last year. Now, here's where the juggling comes in. This is what I'm going to teach you in the juggling, is I'm not going to go back to the table values. You could now. You could go to the table values and graph all those points. I'm just going to look at this and go, oh, if it's multiplied by 2 out front, I'm multiplying all the y values by 2. I don't need to go back to the table values. I can see the y values here. Double y value 0 is 0. Double y value 1 is 2. Double y value 4 is 8. Double y value 9 is 18. I can very quickly get that right off the graph if I so choose. You can also use the table. This is where the juggling part will come in. Am I going to just do it all on the graph, or am I just going to do it all on the table? Everyone will have a different technique. So here I'm just doubling y values right off the graph. Do you understand? I'm not peaking because I'm so good at this. That's not what's happening. I'm just choosing to use the graph to double the y values because I like that visual part of it. Other people are like, no, no, I'll just do it on the table of values. I'll just double it right in the table of values, then I can see the points and I can graph them all. Okay, now connect those up. See how I do? Can I make this pretty smooth looking? Yeah, I did okay. Did I do okay on that one? Oh, I got a little too confident there, but you get the idea. And then I was going to do the other one in black. Same thing. You could go back to the table of values. I'm not going to peek at the table of values, but you could. You could just go to the table of values and graph all the points you see in the table of values. Totally works. I'm going to just do it right off the base graph, off the red graph. I'm just going to multiply all the y values by 1/2. That's going to bother people. They're going to be like, ugh, fractions. So let me give you a little trick. What's half of $100? 50. How did you do that fast? I guarantee whoever said that did not actually multiply by 1/2. The answer is 50. Divide by 2. So multiplying by 1/2 is the same as dividing by 2. That's handy. That's handy to know. That if it's just a 1/2, you could just divide by 2. Okay? So I'm going to divide all these y values by 2 and get the same numbers you get on your table of values back there. 1/2, 4 becomes 2, 9 becomes 4.5, 16 becomes 8. Oh. Do I need the next one? What would the next one be? 4 is 16. 5 is 25. So 12.5. I don't know that I'm really setting up to bust you on that. You could just use the ones you got, and that will give us enough information. But just so you know, you could grab the next one if you needed it. And then the same on the other side. 1/2, 1/2, 1/2, 1/2, and then I get the other side. I did them in different colors. If you don't have them in different colors, you better label them. I will too. This is y equals 1/2 x squared. This one's y equals x squared. And then the blue one, y equals 2x squared. And again, I've used x squared on purpose because I think I get to tap into your prior knowledge from parabolas. This shouldn't blow you away too much because you did this with parabolas last year. How is the graph of 2f at x related to the graph of f at x? So how is the blue related to the red? what's happened here to the graph? That's the fancy words. There's lots of words you could use. The words you'll see most often is vertically stretched by a factor of 2. That's the fancy sentence. Is there other ways to say it? Yes, but that's the one we'll use in math class most often. What's the next question? How is the graph of 1/2 f at x related? Vertically, I'm going to leave a space there, see if we can come up with a good word to use, by a factor of 1/2. Oh, who's it? Someone still got it? Compressed is the word we'll use in math class. There is other words available, but you're going to see that word, so you may as well get used to it. Now, you could argue, you could say, oh, it's vertically compressed by a factor of 2. I'm not going to get distracted by that. I'll be looking and going, did you compress it? I'm not sure what to say there. I like half, vertically compressed by a factor of half. But I've seen people who are adamant that they should say vertically compressed by a factor of 2, but they know what they're talking about. So as long as we get the right answers, we're okay. To stretch the graph, oh, this is the whole lesson right here. If we get this, you can turn off your brain. You can be like, okay, I'm home free on this. To sketch the graph of 2f at x, we can blank the values of f at x by 2. What did I do to the values? What operation was it? Multiply the y values by 2. To sketch the graph of y equals half at x, we could multiply the y values by half. You can do that. Perfectly legitimate, and it's fine. And for some y values, that'll work fine. Half of 8 is 4, no problem. Half of 20 is 10. That can work sometimes. Or you could divide. Here, let me put that down. If you're having any trouble with this at all, you might want to divide the y values by 2. That's the same as multiplying by half. Those two things give the same answer. So that you might find the math easier to just divide by 2 when you want to multiply by a half. Do you have any questions there? Are you loving the printout for this lesson? I'm choosing carefully. I don't know if I'm always making the right choice. There are some days where it's better to just listen and copy. There are other lessons where it's like, no, you need to write all this down and get used to exactly what we're saying here. So I'm trying to balance and make the right choice for each day. However, I leave the choice up to you. I put the notes always up one day in advance. You can always the night before print them out and say, no, I want the base version, and I can print it out and fill that in. Good job, Kyle. Questions here?
What?
No, all good. I was just like, Kyle's copying. I was happy, that's all. Nothing crazy. More time? More time? Goes faster this way, doesn't it? Yeah. But faster doesn't mean better. Extension. Okay, are we with this? To sketch the graph of y equals 3f at x, okay, I've changed the 2 to a 3, we can blank the y values by 3. What would we do to the, what operation?
Well, isn't it the exact same thing as the other question?
It is.
Multiply
It's just multiply by 3. As I said, I don't think there's another shoe to drop here. Sometimes in math lessons, the first half you're like, oh, this is really easy. And then the second half, it's like, what's going on here? Yeah? That's not going to happen here. I'm not going to really say anything more than what we're saying here. To sketch the graph of 1/3 f at x, we could multiply by 1/3. That's fine. But if fractions aren't your favorite, you could get the same answers by dividing, which is the same as dividing the y values by 3. So you could get the same answers by dividing by 3. Any questions there? Is it good? Do you need more time? Is that the full first page already done? We only have the back to do. Yes? More time? We're okay? In general. You don't have to copy this down at all, right? Here it is in general. Not with a 2, not with a 3. It's any A value you want out there. Any number they put out front. If A is greater than 1, then we're talking about a vertical stretch. If A is between 0 and 1, some kind of fraction, 1/3, 1/4, 1/5, 2/3, 3/5, any of those, if it's one of those, it'll be a vertical compression by factor of A. This note says just use the factor you're given. Is the generalization okay? This is just saying not just 2, not just 3, 4, 7, 10, 50, whatever number you want. It's the same deal and all the numbers. Yeah? Okay, the graph of f of x is given. Sketch the graph of 2f of x. Okay, now, big moment in the lesson. I'm going to just move that over and stretch it all I can to get all the space I can. Don't look at the graph. Just talking about this with the calculus people. I'm like, don't stare at the graph first. Stare at the question first and write yourself some information about what's going on. The graph of y equals f of x is given. Sketch the graph of 2f of x. If there's a 2 out front of the graph, what's the transformation going to be? What kind of, is it move it left, move it right? What are we talking about here? Vertical, write it down, folks. Vertical stretch, factor 2. You want to write VS for vertical stretch? I'm in. I'm in. As long as you do it in pencil, I don't care. If you're doing it in pen, no way. Well, okay, one thing at a time. He's copying. One thing. I'm going to buy you a pencil. That's what I'm going to do. I'm going to buy you a pencil that you like. Oh, wait till you see. Have you used a 0.7 millimeter?
Ever since
Who's
grade
got it?
2, I haven't touched a pencil. No,
Who's-
that's facts. Anyone that's ever been in my class knows that they've never seen me write with a pencil.
Well, it's time. It's time to grow up. We all have to do it sometime. Yeah?
I can do it for like 5 seconds. Drone people write with pens though.
Okay, I need help. I need help here. Vertical stretch by factor 2. Tell them what to do. Someone was away for this lesson. And you say vertical stretch by factor 2. They're like, what? What does that mean? What is it you do? Multiply.
By 2.
Multiply.
Oh, by 1.
By 2. Yes, multiply by 2. Multiply what by 2? The y values. Key. Because if I just say multiply by 2, it'll be awfully tempted to multiply my bank balance and my day by 2. No, 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 no. This is vertical stretch. Only multiply the y values by 2. Are you ready? I'm going to do it fairly fast, not to rush the lesson, just to show you how easy this is. I'm multiplying all the y values by 2. This -2 becomes -4. I know it goes off my graph a little bit. This 0 stays at 0. This 2 becomes 4. This 0 stays at 0. This 3 becomes 6 going off the graph, which is annoying. And this 0 stays at 0. That's how quick you can get the points. I just went through and multiplied all the y values by 2. Then I connect up those points. Boop, 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 boop. Let's just jump 2 courses ahead for just a second, okay? So you know where we're going with all this, yeah? Step ahead to advanced functions, then into grade 12 physics for a little bit. All I did was turn the volume up. Yes? Everything's just going to be louder. Same notes, same frequency, just louder. I'll come back in case you're angry about physics for some reason, all right? Yeah. That's when I give you the graph. When I don't give you the graph, it'll be one of your base functions. Yes? Root x. So I'm going to do 2 different ways to handle this at the same time. Get ready for me to do it 2 different ways at the same time so you can choose which way you want to do it. Method 1, make a table of values for the base function. Hopefully you're getting to know root x better all the time. -3, -2, -1. No. 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 Yeah. 0, 1, 2. You could use 2. There's nothing wrong with 2. You're just going to get decimals, that's all. Not really a problem. But if you want nice points, 4, 9, what's this graph go to? 16. Because I can root all those. 0. I can square root all those. Some people use the word square in their assignment. I circled it and marked it right. I wasn't trying to nitpick at you in your assignment. But square root is what we're doing here. I can square root all these values. 1, 2, 3, 4. And I'm going to put those on my graph. So this is me doing it 2 ways at once. I could just graph those. 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. There's my base graph, often called the base function. That is, which function are we talking about here? We're talking about the square root function. There it is. Mine's got a little dot there. I see that. There it got. Okay, so here's me doing it 2 ways at once. What's the 1/3 out there do? First inwards, then what am I going to do? Fancy words first. Vertical compression factor, I say factor 1/3. If somebody wrote factor 3, I'd go, I think I know what you mean. Let's see if you get it right on the graph before I decide whether you've got it right or not. Somebody was away, though, and they say vertical compression by 1/3. What were we talking about? What do I do? Tell me what to do. What is it you do here? You multiply the y values. Y values by 1/3. 0.3. Yeah. But in brackets. You could just divide by 3. Isn't that easier just to divide all the y values by 3? But I'll put a question mark because you've got your choice there. So now, I'm going to try and convince you there's 2 ways to handle this. Graphical people will just be like, I don't need the table of values anymore. I just have to go over here and divide y values by 3. Here it is in blue. You ready? 0 divided by 3, 0. 1 divided by 3, 1/3, right about there. Come on now. There we go. 2 divided by 3 is about 2/3. 3 divided by 3, 1. 4 divided by 3 is 4/3. 4/3. 1 1/3, or 1.3, something right about there. And then I've got my vertical compression factor. Can you see the vertical compression? It's like somebody stepped on the red graph and pushed it downwards. You don't have to do it on the graph, though. You could do it right here on the table. Some people like this. They right up here, they go vertical compression times 1/3. And they just make a new line on their table and go, OK, divide all those by 3. 0, 1/3, 2/3, 1, and 4/3. They get the decimals right here, 0.3, 0.66, 1.33. Don't let the fact that I squeezed it in there make you think I don't like this method. I like both methods. Whichever way makes sense for you. You can do it right on the graph and just divide y values by 3. Or you can do it on your table and go, hold on, let me get it on a table, and then I'll graph it afterwards. And I think speed-wise, there's not one way that's faster than the other necessarily. Any questions about that? Here's what's coming soon. There'll be a lesson where it's like vertically compress it by 1/3, and now move it right 4. Hopefully that doesn't sound too bad, but that's the challenge in this chapter, is to be able to do both those things at once. Do you have any questions there on how to manage this situation? Draw the base function, and then do the transformations that you see on it. Today, only one transformation on there. Do you need more time? Do you have any questions?
Are we gonna go over this one?
The last one?
Yeah.
Oh, yeah. Yeah, yeah. Oh, it's pretty small on my screen here, okay? So I'm going to make this a lot bigger and do that. And is it giving me a little scrolly bar? Yes, it is. Okay. This thing's in the way, so I'll put it down out of the way, okay? This reminds me of the table that's on your quiz. What quiz? The quiz was such a big hit. We've got another quiz coming up. I'll talk more about that in a few minutes, about when it is, okay? Because there's a table like this in your quiz where you just have to look at these and go, what the heck is going on here? The first two rows are already completed. Let's make sure we agree. If you get given 4 root x, the base function is the root x. Those shouldn't be hard to recognize. There's only 4 of them that you have to deal with. And I'll show you which 4 on the website and just right at the end of the lesson. With a 4 out front, now you're supposed to be able to go, okay, that's a vertical stretch factor 4. I want you to use the fancy words over here because the homework will use the fancy words. If you don't use the fancy words, you won't be ready for the fancy words. If it's a 1/5 out front, vertical compression factor 1/5. So let's try a few. Y equals 1/4 x squared. Is there enough information there to go, well, what's the base function?
It's just yx2.
Y equals x squared. Good. And then what's the transformation that's been applied here?
Vertical compression of like 1.1/4.
Yeah, vertical compression factor 1/4. Let's write the full sentences for now. In your homework, you want to write the short forms, VC, VS? Yes, love it. Everybody does. But for your lesson, in the lesson, let's get the fancy words down so you don't get too addicted to the short forms just yet. Oh, this one's different. See, this is what I do on the quiz. I'm like, no, I'll give you different information. Hi, Nathan. Yeah, do it. I understand. You got more important things in my class. I get it.
I'm sorry, Mr.
No. It doesn't hurt my feeling.
The binder too. Where are we going, man?
Base function y equals x. Vertical stretch factor 3. Can you work backwards and go, okay, what function has base function y equals x, and it has a vertical stretch by factor 3? Cameron. Y equals 3x. And if you're right with me, you're sort of like, but we didn't call that vertical stretch in grade 9 when we did it. We called that slope. That's all it was. Slope was a different vertical stretch. So we can still use the same language with those. You don't have to, though. You could, with lines, you don't have to go through that. 5/x. Oh, this is the one you were asking about, Kyle, the other day. This is a problem, okay? So let's just slowly. Make sure you answer the question I asked, because I want to go at this slowly, okay? The question I'm going to ask is, what must the base function be?
X. It's just y equal x.
No.
No, y equal 1/x.
Y equals 1/x. The x is in the denominator. This must be the base function. It's the only 4 base functions we have are, and I've got a sheet for you on the website that shows you the 4 different base functions. We've got x. We've got x squared and the 2 from the investigation, root x and 1/x. The x is in the denominator here. It must have been 1/x. So what happened between 1/x and 5/x? What did someone do to it?
They vertical stretched it by 5.
They vertically stretched it by factor 5. Vertical stretch of factor 5. Okay. Initial training over. If you really want to learn to juggle, it's not that hard to do. But here's what you got to do if you really want to learn to juggle. Here it is. Here comes my juggling lesson. You get out one of something. A beanbag, tennis ball, paper clip, binder clip, and you do this for like hours. You just go like this, and you juggle. Yeah, yeah, yeah. And every time you catch it, you bring it back to the middle and let it go until you can sort of not look at it anymore. You're so good at this that you can sort of not look at it without dropping it, like I just did, yeah? So I can sort of do this without much effort. Hours of that. That's what you've been doing the last couple of nights. You've been learning to handle one transformation at a time. Then you go up and you pick a second one. And hopefully by then, your hands are so trained that you're ready for 2 transformations at once. You know them so well that you can do 2. And do this for hours too. You say hours, I'll be done in minutes. You're making a mistake. If you want to learn to juggle, just do it again and again until you got it. And if you watch my hands, don't watch everything that's going on here. Watch my hands. They're just doing what I was just doing. Yeah? They're just grabbing, middle, grabbing, middle. Every time. Grab, middle, grab, middle, grab, middle. Yeah? That's all. Oh, hit it and still caught it. Yeah, this lesson's in 3D. What's that? No, that's the first time. I just watched a video on it last night.
You said that the other day, too.
Yeah, totally lying. Yeah. This is the turning point of the chapter right here. This next question asks you to juggle. It says base function y equals x squared, but it says vertical compression, factor 1/2, and a vertical translation up 4 units.
Oh, I know.
Y equals 1 over 2 x squared plus 4.
Y equals 1 over 2x squared plus 4. And the first one I used is actually an old friend. It's a parabola. So your grade 10 experience really helps with that one. That's what we're going to be up to now for a few sections, is trying to combine these things and do more than one at once. That's when it gets, is it going to get really difficult? I don't know. Not bad. Is this the last 3? I got 3 more to go and I'm done. Sorry? Lesson took longer than I wanted. We'll do the other lesson tomorrow. Kyle, are you going to answer the next question? Is that what's going to happen?
Yeah.
Oh, okay. Well, what's the base function?
I think it's just y, the root, like simple thing.
Yeah, so recognizing the base functions won't be all that hard. If you see square root, then square root's the base function.
You just get rid of all the numbers and stuff, basically.
He's phrasing it perfectly. Ignore all the numbers and stuff and just look at what it is without all that stuff. We want the base function. Okay, let me ask a different question though, because this will help as things get crazy. How many transformations do you see there?
2.
2. That helps in these questions to write 2 little dots and go, what are we talking about here? How many transformations do we have? Okay, there's 2. What are they? Who's ready? Who's got this?
Oh, I got this.
Kyle's got it. Go.
So it's vertical stretch of 3,
Vertical stretch,
and then it wants
factor 3, hang on. And then what?
down 2.
Down 2. Is it down 2? Is it left 2? Is it right 2? Is it up 2? You see? Now we're juggling. Which one is it when it's minus 2 inside the function? Ben? He says right 2.
Whoa.
Horizontal translation right 2. On the test, if you just write right 2, am I going to mark it right? The answer is yes, but I'll be like, you can't on a test write all the words for me? I get in your homework you're just writing right 2, but come on, it's a test. Let's put an effort in here. It's like some of your assignments, like you wrote as few words as possible. I don't know if that's the right approach in assignments. Assignments take the moment to write those extra words, full sentence. Yes, Kyle?
That doesn't make sense though, because like I thought it was only if it's in like, okay, so
Hold on. Let me just write an example beside it. I think the one that you're thinking about. If it was this, that's down 2. When the minus 2's outside of the base function.
but when it's inside, what makes it x? Because the other one didn't make it.
Oh, yeah.
no,
Now you're ready for that other video now, I think. The other video walks through it carefully and goes, when will it be a horizontal? And when it's inside the function we're talking about, that's what makes it horizontal. And then when it's horizontal, minus 2, which you'd think would be left 2, is actually right 2. So there, there's a little bit more to this. Like it's a bowling pin and an apple and a tennis ball going off your foot. Like there's a little bit going on here now to keep track of all these little things.
The next one, wait.
Okay, so this one, I tried to go a little bit difficult, back to easy, a little bit difficult, back to easy. This is back with x squareds. What do you got?
Y equals 3 square root x squared plus 2.
Hold on. Y equals 3, and I'm just going to call you out on what you said, because you said square root.
3 plus 2
Square x squared.
3x squared. I wondered maybe if you wrote the right thing and said the wrong thing but wrote the right thing. X, ooh, I'm tentative.
What do you mean back?
Squared, yes. Go ahead, keep talking.
X squared plus 2 and then -5.
Minus 5. Okay, so I agree with the minus 5 over here. That I like, because it's down 5. But if we're going to go left 2, it has to be inside the function. That means inside the squared. Yeah? And now left 2. So what's plus 2? You think it would be minus. Doesn't it make more sense to be minus? But it's not. It doesn't work. It's actually the other way around. All right. Last one. Base function. I don't know the base function. This bothers people when that f is there. Like, well, what base function? We don't know. So I'm not going to write f at x here. You could. It would be correct to write f at x. I'm going to write unknown. We don't know what the base function is. But that doesn't mean we can't talk about the transformations. We can talk about the transformations. How many is there? This is not an easy question. To know how many transformations are we talking about? Hazel. There's 4, she says. She's so right. And I'm going to hopefully get 4 different people to answer the 4 different ones. Hazel, what are you going to do? Are you going to pick off one of the hard ones or one of the easy ones? She's going to go after one of the hard ones. You decide if you agree with her that the one she chooses is difficult. Go ahead. What do you got?
There's a reflection in the x-axis.
Good. I'm going to use one extra word. What you wrote is perfectly correct, and I mark it right every time. But I'm going to use one extra word. I'm going to say a vertical reflection in the x-axis. And as I write that, maybe for the first time you're going, wait a minute, this juggling thing might need my full attention. Yeah? Who's got another of the 4? I'm going to ask the same question if you're going after an easy one. Carter, are you going after an easy one or a hard one?
This one's like pretty easy.
He thinks it's pretty easy, okay.
Vertically compressed by a factor of 2/3.
Yeah. If he thinks that's easy, he's in good shape. Because I think the last 2 are the easy ones in these. But anyways, vertical compression factor 2/3. How do you know it's a compression? Because it's less than 1. Yeah, between 0 and 1. That's what that was saying earlier, between 0 and 1. Then the last 2, maybe somebody could do both of them at once. Because the last 2, I think, well, you'll find the easier ones. Kyle, you got these?
Vertical translation up 7.
I'm going to do it last, and there's no reason to do it last.
And then horizontal translation.
Oh, hold on. Vertical translation up 7, and then horizontal translation.
Right 5.
I got to check to see if you're right.
In the brackets.
It's in the brackets. Minus 5 makes you think left,
But it's right.
but it's not. It's right 5. Good. Your quiz asks exactly that stuff. It asks you to fill in one of these tables where you're like, can you go back and forth with all those? I'm giving that away. When's the quiz? Well, it's after the combining. No, we got to do horizontal stretches, then a day combining them all, and then it's got to be after that. So let's time this out. Wednesday, Thursday, Friday to catch up on the homework. The quiz will be Monday. So you have the whole weekend to go over this stuff and get it figured out, okay? Well, are there any questions there before I wrap up the video?
Why not on Friday?
If people on the homework Thursday have trouble, I want them to be able to come back Friday and say, I didn't get number 7, whatever. And then they have the weekend to sort all that out, okay? Or maybe somebody has